So we want to do 8.4 number 23, which says find the y-intercepts, the x-intercepts, and the vertex of this thing. Y is the quantity 2x minus 3 times the quantity x plus 4. So how do I do that?
Set it equal to 0 and a 1 0 factor.
Yep.
Okay, what's that getting you?
That would be
The x.
X-intercepts? Okay. So for part B, so if I do 0 is 2x minus 3 times x plus 4.
Well, can't we do the 0 product rule?
Good.
Oh,
Then I should do the zero product rule. I could. How else could you do this? You didn't.
You get to boil it out.
I foiled it out.
Yeah, you could FOIL it out and then like complete the square or apply the quadratic formula or something. It is a lot easier to use the zero product rule right here. It's a lot less prone to error. So I've got 2x minus 3 is 0 or 4x plus 4 is 0. Okay. Which one's easy?
X
plus 4.
X plus 4 is 0 is easy. I subtract 4 from both sides. I get x is negative 4. How about this guy? 2x minus 3 is 0. What do you do with that? Okay. So we add 3. We get 2x is 3. Then what? Divide by 2. So you get x is 3 halves. Okay, so x-intercepts. Wait, are those x-intercepts?
Yes.
Yep.
How did you know that?
Because you're supposed to do 0 for y.
Yeah, I plugged in 0 for the output, right? So these are the inputs that give me 0 as an output. Okay, so I might write negative 4, 3 halves. X-intercept R. Okay, now what? Why did I answer part B first? Sure, okay.
And you can plug them in.
How do I answer part A?
You plug in 0 for x.
Yeah, I'm looking for f of 0. Really, I would prefer it, right? If instead of writing y equals, if we wrote f of x was, right? So really here we're looking for f of 0. So what's f of 0?
Negative 4.
F of 0 is, how did you get that?
Because 2 times 0 is 0, and 4 plus 0 is 0, so negative 3 times 4 is negative 5.
Nice, cool. So we plug in 0 for the x's, and then we say, okay, that piece is 0, that piece is 0. So I got negative 3 times positive 4 gives me negative 12. So I'd write the y-intercept is negative 12. All right, how about this thing about a vertex? Where do I get that from?
Options.
Yeah, I have a couple options. Where are my options?
The lowest one on the graph.
Yeah, but how do I find that?
The FOIL out the number and then plug in what did I do?
You see that? If I FOIL this
Oh,
thing
you plug
out,
in negative
then it'll be in
2a.
that ax squared plus bx plus c form. And then I could use that rule about the vertex is above negative b over 2a. Or, what else could you do?
Couldn't you add it to negative 5?
Yeah, or you can average the
Oh.
x-intercepts. Why does averaging the x-intercepts work?
Because
The middle of the.
Yeah, it's symmetrical between them, right? Okay, so I just want to know what the average of these two numbers is.
this is where I messed up because mine's are so different from the ones in the book.
Mine too.
Okay, so the average of these two numbers should be negative 4 plus 3 halves all over 2. You guys believe that's how you average numbers?
Yeah.
Even when one of them is negative? Okay, so
Okay, okay.
if you were taking physics, you might recognize this as the lever law, but whatever. Okay, so you average these two numbers. So what do I get on the top? Let's just remember fractions for a second. Okay, so 4 is 8 halves. So I've got negative 5 halves divided by 2.
Negative 5.
Good. So you maybe do this. So this is negative 5 halves times 1 half is negative 5 quarters. Or you could just think, what would happen if you had negative 5 halves of something and wanted to split it among two people? That might be weirder. But you get this negative 5 quarters number. Instead of vertex?
No, that's the X.
Okay, but what's a vertex? A vertex is a point in the xy plane, right? That's a number. Yeah, so I should take that number, plug it in here to get the y value. Okay, see that? I'm doing that because a point on the graph is an x comma f of x pair, right? So my vertex is going to happen at negative, oops, I was writing the answers in green. So my vertex is going to happen at negative 5 quarters comma f of negative 5 quarters. Did you all see that?
And that's a complete answer, but like that.
We probably should simplify this thing. So how do I simplify that then?
Look in the equation.
Okay, so I want to calculate f of negative 5 quarters. So that's twice negative 5 quarters minus 3 times negative 5 quarters plus 4. Scariness?
Dash.
Yeah, probably a little bit. Just calmness and one step at a time. So what's the first thing I should do in this first param? Okay, I could do negative 10 over 4 minus 3, or I could do,
No, you do times.
but I could do negative 5 halves minus 3. You see that? No. Okay, let's go with negative 10 quarters. So we've got negative 10 quarters minus 3. And what do I need to do in this piece?
Common bottoms.
Yeah, I need to find common bottoms in there to add things together, right?
Yep.
So how many fourths is 16? 16 fourths. So when I add these together, what am I left with? 11 fourths. You guys all see that? Okay, what do I need over here now?
Common bottom.
Common bottom. What's the common bottom over here? 4 again.
12 on top.
So 3 is 12 fourths, right? So what do you get?
1/2, 2 fourths or 1/2.
So you get 2 fourths times your 11 fourths from the other one. Am I nuts?
Yes, you are.
What did he?
You added there. It's a negative 12
But it-
over 4.
Yeah, so it should be negative
22 over 4.
Good call. Okay, so I got negative 22 quarters times 11 quarters. Can you do any better than this?
You simplify the 22.
Yeah, you can cancel a 2 here, right? So that's negative 11 halves times 11 quarters. Gives us all told
Negative 122
Negative 121 over
8.
8. So we should really replace our f of negative 5/4 here with our negative 121/8. So there's our 3 answers.
Yep.
Oops. Probably should say what those are, and what that is. Cool. Questions? Thanks. Horrible fractionness?
Yeah, that's bad.
Yeah,
That's
but
where I went wrong.
calm, one step at a time. Find your common bottoms when you need them. Remember to cancel.
It's not hard, it's just inconvenient.
Yeah, totally.